This share nibble is on IMS APIs. You don't know what you don't know. This is a smaller version of one of the full-length sessions at the Share Major Conference. So let's get started. When we talk about APIs, or application programming interfaces, most people will assume, oh, it's so easy, I just do it, I do one, I have no issues, and I don't have to worry about the back-end systems. Well, I'm kind of here to tell you that's not exactly right. Because what you're going to do is you're going to start, you're going to fail, you're going to go back and start again, and you're going to keep trying and failing until you come up with success. And eventually you're going to come to the point where even once you've succeeded, you've got to go back and change the APIs. Since we're talking about IMS APIs, most people are going to say, yep, been there, done that. But what is the number one way customers are trying to create APIs today? Most of the people we talk to are trying to do this by writing code. And they can't keep up with the workload demand. They can't keep up with the number of services. So that's the first thing I'm saying is don't write new code. The second one is we hear, oh, I've got an enterprise service bus or an ESB, so I really don't need to develop any new APIs. I just treat the legacy system as this little box on the lower right and I talk to it. Well, in that box, maybe what you want to do is you want to do REST and SOAP, and you want to talk to online applications, you want to talk to transactions, and you want to talk to external services, and maybe the mainframe is talking out through the ESB2, but you need a way to do that where you create maybe some intelligent workflows. So what about performance? We hear all the time, oh, APIs are slow. The mainframe is not slow, but the APIs are slow. And why is that? So let's kind of look at most people's view. As on the left, you've got tablets, mobile phones, laptops, whatever. And on the right, you've got the mainframe. Since we're talking about a ZOS mainframe running IMS, in the lower right hand, we have a transaction we want to expose to the API. So let's figure out what is inside that box. Well, you've got the network. You've got application servers probably. You've got traffic managers or local network devices. Maybe you have an application server or an API server running out on the mid-tier. And you've got other traffic managers. And then on the mainframe, you've probably got TCP/IP and IMS Connect. So with all of those pieces from the left to the right, what can go wrong? Well, maybe some of the stuff you need to start looking at is on IMS, things you can control, the number of message processing regions that you have. Do you have enough message processing regions to handle the transaction load? Also, in those message processing regions are the limit count set where you can have some parallelism where you're not having transactions queuing, some basic IMS tuning techniques. Also, are you doing callouts? Are you having your IMS transaction act as a client? If so, maybe you want an MP region to be segregated out where it's only doing callouts so it's not blocking other transactions. Also, if you're doing IMS Connect, you want to have IMS Connect extensions installed to manage the performance of what's happening inside the IMS Connect address space. TCP/IP, you may need to get your TCP/IP group to look at the number of TCP/IP buffers. Also, is ATTLS fully configured to handle security and inbound and outbound ports? On your application, on your multiple servers, do you have traffic managers that are doing global routing or local routing? Do you have sticky sessions where sessions are being held open? You may need your network group to look at those. Also on your network, are you using a wired network like from a laptop or a desktop computer? Are you using a cell phone going through 4G or 5G? Are you using a tablet or other devices going through Wi-Fi? Maybe you need to tune that. Also, maybe you have to tune the underlying application server running on the API server, whether it's Tomcat or whether system you're running, or you need to tune Linux itself. Maybe you need to tune the application. Maybe the application is bringing back too much data for what they really need. And you may need to tune, in this case, if you're using like IAB, you may want to tune the application server or whatever you're using. So what else don't I know about? Well, how old are your back-end legacy systems? Have they been written for 30 or 40 years ago? What technologies are they using? Are they using inbound sorts? Are they using technology inside the application? Is the application code structured or unstructured? Did they break out and call subroutines? Is the logic self-contained? And did your core applications first start out as commercial offerings that the company bought, modified, brought other consultants in? What third-party components are embedded in the code? Did the code originally call other products that is still in there that you didn't know about? How complex is the code and the data structure design? Where we see a lot of this is customers who originally designed the program with a working storage section that is like a 8,000 byte buffer. And over the years, anytime they've come up with a new file format, they just do a redefine of another data format or another data structure. And over the years, it's gotten very convoluted, but you need to know which format you want to use to export in the API. And does your application group actually understand the application? In some cases, the application people who wrote this are no longer around, and the understanding locally doesn't exist. So, and how many coding standards have been used over the years? We have customers that started out with a code generator, then they went to a local consulting company, then they brought in another consulting company, and each one of those companies codes it in a different way. And most mainframe applications were designed to interact with 3270 terminals. They were designed to run from a screen with an end user making the choice of go to screen 1, then to screen 2, and on screen 2 I select option 5 and keep going. So how do you capture that in an API? Also, what we're saying here is, as I mentioned earlier, is we don't want to change the code. The integration technologies you choose should be transparent to the back-end systems without changing them. If you change the legacy code, maybe you're thinking you'll change it to recognize it's being called by an API. It can introduce other complexity and code to manage that you didn't count on. Sometimes we talk about microservices, but we have found that fine-grained APIs or microservices may be easier to build, but put more work onto the consumer. The more intelligent the API, the less effort for the API consumer processing logic, and I'll show you an example of that in a second. Also, one of my sales friends, his line is, legacy mainframe apps are like a box of chocolates. It's hard to see what is inside. And there's also other stuff you need to be concerned about. Things about attributes that the application is sensitive to on the screen, message switching between multiple programs, multiple input and output messages, and how do you decide how to map those? Variable length, multi-part messages with different layouts, and how do you map those into a usable API? Complex COBOL structures like a redefines or occurs depending on. Things like null terminations or non-standard coding techniques. Screen macros that, as I mentioned, these applications were meant to be driven by a person, and by default they'll zero fill or numeric fill or space fill fields. Well, the program doesn't know that, and when you try to API enable it, you have to know that's the way it was designed. Also, the whole idea of conversations. How are you going to expose conversations? External and 3270 applications, how are you going to communicate with those? Complex conversational transactions, especially conversations that may get all the way to the end and then roll back what happened. So what I was talking about earlier is sometimes you have to understand the environment. If your line of business or your applications have an API that can be satisfied with one service, or we'll call it a microservice, in a banking example, something like get checking or get savings or get car loan, maybe that's okay. Maybe through one RESTful API, you have one transaction that has an input and an output, and it maps to an input and output message, and that's okay. That's very simple. But in most cases, you have to worry about other things. You have to worry about, well, what if you have a complex transaction that has an input message and two output formats, or data, you have to maybe call one, then call another one if a certain situation exists, where you have to do data manipulation or some sort of flow control, and then you have screen macros, you have message switching. And so what that means is you're pushing to the left that the consumer has to handle the interaction of all those fields. So if you could create an intelligent business process API to orchestrate all those together and to create a super service, maybe called like Get Customer, or an intelligent workflow, and the ability to call outbound, maybe that's what we're looking at. So I know I went fast through a lot of this, but these are things we're going to talk about in depth when you talk about IMS APIs. You don't know what you don't know. And thank you for attending.